All right, so we're recording, which means the class has officially started. I appreciate everybody for coming in. We've got 6 students here. Don't forget discussions, and also that our hard deadline is 59 on Sunday night. So this is our last week. Everybody here can do it. I think everybody is doing fine. I can double check. Mr. Ferguson, I know Lorraine's already looked over. I looked at Deidre's. Deidre's doing fine. Donald Ferguson, you're doing well. And Margaret Ann. Oh yeah. So, and you can tell, you can tell people that show up and who doesn't by their grades. So.
Yeah, if I don't show up ever, it's really showing in my grade.
69 or 94. Hey, whatever, man. Yeah, I said you only have a 3, so. All right, so I've got chapter 11 pulled up. Let me share my screen. Do we have someone else come in? 1, 2, 3, 4, 5, 6, 7. We got somebody keeps bouncing around. Okay.
My computer kicked me out.
Oh, okay. I was trying to look and see who was missing. Let's just start from the beginning on our compound interest on 11 homework. Yeah, am I sharing my screen? There we go. And I don't know why, but every time I share my screen, it messes up my where all my screens are in Zoom. So I have to move them around. All right, so compound interest. Now there was a saying, I believe it was they say it was said by Einstein that like something along the lines of compound interest was one of the 8 wonders of the world. I don't think he really said it, but whoever said it is right. Compound interest is where you build on you build on money that you've already got interest on. So, you know, if you had 10% interest and you put $1 in, next year you have $1.10, and then the next year after that you'll have $1.21. Then the next year after that you'll have, you know, $1.35. I think it's actually 33 or 34. And so you're building on top of the interest you've already made.
Is there a way you can enlarge that?
Sure. Is that better?
A little bit. I'm gonna have to hold it and look at it. No, I really can't see it, but it's okay.
Yeah, that's about as big as I can make it without losing part of the
okay,
page.
I just wish I would have brought my tablet, but
Your web, the actual questions on the page are bigger than your whatchamacallit over here, Excel. Excel looks really skinny to me.
It is
Okay.
really skinny because I don't need all those cells. I can do with a little bit more. Let me see if I can enlarge it just a little bit. Okay.
Okay.
That's as big as I can make it. So let's talk about some of on this problem, some of the nomenclature. So periods is equal to years times the periods divided by years. And then your rate per period is your nominal rate over the periods per year. So let's kind of look at this one. I'm sorry, not divided by, it's periods per year. And I hate it when they do that. So your periods are going to be years times periods per year. And there are 4 quarters in a year. We need to remember that. There's 4 quarters everywhere, but there's 4 quarters in a year. So on this one, they give us the nominal rate, which is 4. The term of investment, which is 6 years times the 4 quarters, 24. And then that equals to 1%, because the nominal rate is going to be when they give you an interest rate, it's always in a yearly fashion. So when you see something at 6.7%, 8%, whatever, just like your mortgage. Caitlin, let me make sure. Let me write you down, because if I give you your points right now, then you everybody else is great. Jeez Louise, not even my notebook.
Love that background you got going on there.
That is the dystopian future we're looking forward to.
Yeah, looks great.
If things keep going the way they're going, we're gonna have a dystopian future.
What does that mean?
That means a really bad future where,
Oh, don't be looking at, don't be laughing at me.
people are cannibals and all that other good stuff.
Joking.
The background is actually, I believe, the movie Blade Runner. Anybody see Blade Runner?
No.
I don't know what to do with y'all. One of the greatest movies ever made. We're talking about Harrison Ford, Rutger Howard. I just can't. So we have 24 periods per year, and your nominal rate is number of periods per year. So that's pretty easy to find the compounding periods and the rate per period, because that's what they're looking for right here.
Okay, what number are you doing?
Number 1.
Okay, I'm not sure. I can't see how you're setting it up, and I don't know which formula to use. So,
Because you can't see, right? Or you can't see
or
the
I
screen.
can't see. My phone's too small.
All right, and we got Brandy in. Brandy down. Did anybody show up to Bob's class today? Anybody doing double duty?
From Bob, he's like, "Hey, join my class." I was like, "Steve, not have a class tonight."
You can do both.
It's okay, because I got kicked out last week, so.
Yeah, but you were in ethics.
I know.
Okay, so Brian invests $11,500 at 6% interest, compounded semi-annually for 2 years. Manually calculate compound in dollars for his investment. So 6% rate is a yearly rate, right? And let's just look at the solution, because they give us kind of a long explanation for something that. Now, this formula is one you guys need to know right here. Interest is equal to principal times rate times time. Hey, Brandy, we'll get you there. Now, Caitlin, you're Brave, right?
Yeah, I am.
Okay. It said Gailey, and I was thinking, well, maybe I had somebody else named Caitlin, because I forget.
No, that's my married name.
Gotcha. My married name is Diamond, by the way. I don't know if that really counts.
That's cool.
The way does it look amused? Okay,
Shaking my
so
head.
the compound amount, also called future value. Now you have present value, future value. All right, is the total amount of the principal and accumulated interest at the end of an investment. Compound interest is interest that is applied a number of times during the term of an investment. With compound interest, the interest earned for each period is reinvested in the previous principal for the next calculation. The previous principal plus interest that becomes a new principal will earn interest in the next period. Now, one thing that people don't understand is we have the Federal Reserve, they set an interest rate. The interest rate is what they let the banks borrow from them, and it's the lowest interest rate that you have. Every other interest rate builds from that prime interest rate. And if you look, or if you've heard, the Federal Reserve has been increasing the interest rate in order to curb inflation. So a little economics for you here. So remember that interest is equal to principal times rate times time. So when they say semi-annually, that means the interest is calculated twice per year. Therefore, your time is half a year, right? Anybody disagree with that? Because
Right.
that's how, yeah, that's how it's compounded, is semi-annually, so every half year. Usually it's done every month, okay? Just like when you buy a car, the formula is kind of the same. When you buy a car or a house, they tack that interest on every month, and then they divide that interest rate by 12. So if you have a 12% interest rate, you get 1% a month, just as an example. Compounding semi-annually, we got to that. Total number of compounding periods is 2 years. Multiply the number of periods per year. All right. So
Yeah, Central 227-229 is requesting evening
Oh.
med. 227-229.
So the total number of compounding periods will be the number of years, multiply the number of periods per year. So total number of compounding periods is 2 years times 2 compounding periods a year. So we have the compounding periods being 4. Overall, the compounding period, simple interest formula will be applied 4 times. Interest is compounded twice a year. So the amount of time it's used a simple interest formula is T is equal to 1/2. So the original investment is 11,500. That's his present value. All right. It will earn 6% a year interest. That's 6% a year, which is 3% every 6 months, since we're doing it semi-annually. Okay, and don't forget, is when they give you a percent, you need to change that into a decimal. A percent is used for, hold on a second, guys.
So futuristic. You put that fan right in the middle of the city. I love it.
Well, you know, you guys got me sweating up here. So always put the percentage into a decimal. Percentage is used so you can kind of understand, you know, that 6% is 6 out of 100. But in order to do the math part, you need to actually turn it into a decimal. So what we're going to do here is interest is equal to principal times rate times time, and that's your simple interest formula. So 11,500 times 6% at a half a year, that is $345. And that is done. That is for the first 6 months. So at the end of the first 6 months, you're going to have 11,500. I'll put up here on the spreadsheet, 11,500 plus $345. So those two added together. So after the first 6 months, you're going to have this much money. Let me turn that into money if I can. This is so skinny, I don't get all the things. So I got to do it a little differently. So you have $11,845. So your next thing is you're going to do is you're going to take the $11,845 times your 6% times 1/2, which is we're going to call 0.5. So we're going to multiply those together. Not like that, we're not. Okay, so the next time you get $355.35. If you notice, because that 345 you got and you're adding the interest onto it, you get a little bit more. So now we have $11,845 plus our 355.35. Now this is the hard way to do it, just so you know. So I'm gonna add those two together. And so after the first year, you have, let's see if I widen this out a little bit. There we go. You have $12,200.35. And you're just going to keep, you're going to do the same process for the next two periods for this last year. Okay. So in the end, we go down here to the end, 1,245. You're going to do interest for period 3, which is going to give you, and if you notice, the first bit of interest was what, $345. By your third period, you got $366. All right, and by the fourth period, you're going to have $376. So in the end, his $11,500 investment turns into a $12,943 bit of money. Now, let's look here. He got 345, 355.35. We go to the other ones, 36601 and 376.99. If I add those together, okay, that's $1,443.35. Now I'm going to divide that by his original 11,500. I'm sorry, yeah. If you notice, he'll get more than 6%. He ended up with a 12% return rate, which divide that by 2, that's going to be 6.25%. So he got a little bit more. Caitlin's upside down. He's got a little bit more in interest than it showed in his original interest rate. And that's just going to become larger and larger and larger. Any questions on that? Because I feel like I fumbled on it a little bit.
So what was the final answer though? Did I get it wrong?
The final answer was, let's look at the question here. $12,943.35.
Yeah, that's what I put in. Hold on, I might be dyslexic. Yeah, $12,943.35. They're not taking it.
Well, okay, what was your original?
Oh,
Make
I
sure you don't
forgot
have
your
different-
numbers are different.
Not always, but most of the time.
13,500, 8% for 2 years.
Okay, so you're going to have different numbers, but you still
Dadgummit.
follow the same process.
All
And like I
right.
said, this is the long way. There is a formula to do it a little bit different. Okay, so now they're having us use a table.
I'm gonna
Okay,
need to make an
they're having us
appointment.
use a table. So let's look at this. If the principal is $6,000 for 4
You lost
years.
me. I have no clue what you did. But
Well, I think part of it is you're working on that small screen. I wish you had a bigger screen so you see better, Deidre.
well, I
but
don't
the
even know what problem. I don't even know what problem you were doing. I don't even know how you got what you got. I'm not sure how you got it. I mean, I don't know. Okay, go ahead.
But the cool part is you can go back and watch this video on a larger screen, and I am recording, correct? Did hit record? I want to make sure I did. Yes. Okay. So you
I'll
can go
try
back
to make
and,
it fun.
yeah, you go back and watch this on a larger screen, and I think that'll help a lot. But that was number 2.
Okay, I didn't even get number 1. I didn't even know you did number 1. So that's how. Okay.
Okay, so let's look at this thing here. They give us 11% interest for 4 years, and it's compounded annually. So it's only compounded once a year. So what we're going to do is go to our table, which is very, very tiny. So you're going to have to look at it on that. So, but we have, what do we say? Help me out here. 4 periods of 11 interest. So I'm going to go down the side by 4 periods, and I'm going to go to 11% interest. We have to go farther down. 4% at 11% interest gives us a number of 1.51807. Let me copy that and put it in our spreadsheet. Okay. So what we're going to have to do here is we're going to take our original principal, $6,000, and use it and multiply it by that number we got on the chart. So all in all, $6,000 at 11% interest for 4 years compounded annually. In the end, you get $9,108.42. So, and here in the question, they ask you what the compound amount was. So that's going to be that $9,108.42. They want to know what the interest is. So you're going to subtract the original 6,000 from what you have. So you're going to come up with 3108.42. So the interest amount is 3,000 and the off a $6,000 investment. And if they compounded it monthly, you would get a larger number than that. Compound it yearly kind of gives you it gives you less money. So and here you can see how it's done. So I got the solution and explanation up. So Deidre, that will help you as well, because when you pull this up on a larger screen, you're not only we have my explanation, we'll have the explanation of the that the book gives you.
I'm so sorry. Are we doing interest in AMP, the homework?
Yeah, we're on chapter 11. We skipped chapter 10 and 13 because basically we have limited time, and the compound interest is probably one of the more complicated ones. Okay. So
Okay, I got it.
Number 4.
Sorry.
No problem, Caitlin. If you have a question,
Okay.
there are no stupid questions. Or like my drill sergeant told us, there are no stupid questions, just stupid people. But yeah, he wasn't very nice. So where we're at. Suppose you invest $3,000 at 6% interest compounded quarterly for 5 years. Use table 11.1 to calculate the compound interest of your investment. Okay, so here's how you got to do this one. Before finding the compound interest, we must first find the final value of the investment after all the compounding periods, which we already know because we did that in the last one. One way to find the value after all the compounding periods is to use a compound interest table, which we used. To use a compound interest table, we must know the interest rate per period and the number of compounding periods. So they do it quarterly, which is 4 times a year for 5 years. So 4 times 5 is you're going to 20. You're going to have a total of 20 compounding periods. All right. But the interest rate they give us is 6%, and that's always yearly. Whenever they give you an interest rate, it's always a yearly interest rate. And I can't, stress that enough. So the interest rate per period is going to be your 6% divided by the number of periods per year. If it's semi-annually, it'd be 2. Since it's quarterly, it'll be 4. So 6% divided by 4 is 1.5% interest. Now, the total number of periods, like we already said, was 20. And they give us a sample of the chart. What do we say? It was 1.5% interest, which is 1.5 for 20. So that gives us a what do they call this? It's just a compound interest table, so we'll just go with that. My brain is losing it. Okay, so we're going to take 1.34686 and we're going to multiply that times our table factor is 1.34686. We're going to multiply that times the $3,000. That was our original. Okay. And so we're going to know our total investment is our total amount of the end amount after 20 years of the investment is 40,40,58. So after 5 years at 6% interest compounded quarterly, the initial $3,000 will be worth 40,40,58. Of concern is the compound interest. This is found by subtracting the principal from the compound amount. So our compound amount minus the 3,000 gives us what we actually gained in interest, which is 1040.58. And once again, I am going to come back to the top. We see what, and we need to know what they were asking for. They were asking for the compound interest. So I'm going to slowly come up. So if you need to go back to it in the video, you can pause and read this, and I'm not just zooming through it. Because I know I'm trying to zoom through it a little bit because, like I said, we have limited time. Although, as everybody knows, I will stay here as long as humanly possible. I'm going to skip number 5 because we're back to the table. But I will go slow on the explanation so we can always go back to it. And you can read it. All right, number 6. Now, Maria invests $4,900 at 6% interest compounding quarterly for 1 year. Nope, that's still another table one. So we are going to just slowly through that because I want to get some of the more complicated stuff. And you're going to have to look. I'm going back on the table they give you. That is just a hyperlink. So just click on it. It'll open up another tab. So let's just go through this very slowly. That way we have what we need. And remember, when you get your final answer, because they're looking for, you know, your full rate, which we talked about earlier. So once you get that, you take the decimal 2 places to the right, and that gives you your percentage. Okay, so as a savings plan for college, when their son Bob was born, the Wilburns deposited $10,000 in the account, paying 9% compounded annually. How much would the account be worth when Bob is 18 years old? So once again, we go back to the table. 9% at 18 periods. All right, it's done yearly. So go back to the table. Because 18 periods, because it is compounded yearly, and they give that to you. Did somebody show up? Chitona, good to see you. Let me write you down here. So don't forget to give you points. Okay, so I got Brandy, Caitlin, Callie, Sydney, Chitona, Lorraine, Deborah, and Donald. Okay, so I need to put these 3 in. Once again, we're back at the table. I just want to skip through it because I want to get to some of the good stuff. All right, now we have a formula. Okay, A is equal to P times 1 plus I to the n power. So now we're using exponents. Does everybody know what exponents are?
Nope. I'm just
Okay.
kidding. I'm
Oh.
just kidding.
An exponent, see what you did to me. An exponent is the number of times multiply a number by itself. Okay. And in PEMDAS, which is what is PEMDAS? Parentheses, exponents, multiplication, division, and the order which they come, and addition and subtraction, which order which they come. So that gives you the order on how to solve these. So what you're going to do is you're going to decide, you're going to calculate what's in the exponents or in the inside the parentheses here. You're going to take that to whatever power we get and then multiply it times P. Okay, I is going to be your interest rate, and that's going to be your nominal rate divided by periods per year. And it's compounded monthly. So that's a little more like reality. And you're doing it for 2 years. So my nominal rate is 18, they say 18%? Yeah, 18% divided by 12 compounding periods per year. So every month you get 1.5% interest. Now, this is a pretty high rate, but if you're on the receiving end of it, like you give somebody a loan, like these payday loan places, all right, this is their end of how they make their money. The total number of compounding periods will be the number of years multiplied by the number of compounding periods per year. The investment accrues interest compounded monthly for 2 years. That's where we get our exponential growth from. Find a total number of compounding periods N. So N is going to be equal to the number of years times number of compounding periods per year. So that's going to be 24, going to be our N. To use the compound interest formula, the interest rate per period must be expressed as a decimal. We know that. I've harped on that. You got to change it into a decimal. It doesn't, a percentage doesn't do us any good. So I is going to be 1.5%, which is equal to 0.015 represented as a decimal. Okay, there are 24 compounding periods, giving N is equal to 24. So we have I, we have N, we have P, because P is our principal, our original investment, which I keep calling present value because I keep going back to my finance background. So we have P, we have our interest, and we have our number of periods. So 19,000 times 1 plus 0.015 to the 24th power. Now I'm going to do this on the spreadsheet. Okay. So we have 19,000. Then we have 0.015. We have 24. Now that's the information we had to figure out, right? Now, remember what I said, the first thing we want to do is what's inside the parentheses. So I'm going to take 1 plus this, and doggone it, to do what's in the parentheses first. Then PEMDAS, parentheses, exponents, multiplication, division in order we come, addition and subtraction in the order which they come. So the next thing by PEMDAS is we take this number that we figured in the parentheses, which is 1.015, and we're going to multiply it by itself 24 times. So what this represents is 0.015 times 1.015 times 1.015 done 24 times. But the cool part is, since I'm in Excel, I can just figure that out for myself. Is that right? 1.015 to the 24th power. Doggone it. 1.015 to the 24th power. Okay, there we go. 1.49295028. Then we're going to multiply that, because this is like skipping the table. This is what you'd get a similar number in the table. So I'm going to take that number and multiply it times our 19,000. And let me turn this into money. So if we invest $19,000 for 2 years, compounded monthly at 18% interest, at the end of the 2 years, our original 19,000 investment will gain us be worth 27,160.55. And to find the interest, remember, we take this minus this, okay, and that gives us how much interest we earn. So if I take that number divided by my original investment, we actually got 42.95% interest total. And I can divide that by, and that was 2 years, right?
Hey, Mr. Diamond,
Yes.
can you hear me? Hey, I'm gonna hop off here early. My tummy's been bothering me today, so I just want to let you know that's okay.
Okay. I'll see you later. Hey, if you need some help on this, holler at me and maybe
I
you can
will.
come in again.
I'll holler at you tomorrow and we'll pick a time.
Okay.
All right,
So-
thank you.
You're welcome. So our 18% interest actually netted us, because of compound interest, 21.48% per year. All right, that's how compounding works. Because you're getting interest on the interest you received last time, and it just builds on top of itself. Once again, I'm going to start here at the top. Let me actually do the problem. And then, oh, that's the problem. Sorry, I went too far. Number 8. And I'm just going to slowly go through the explanation so you guys can find a stopping point and read this as you go through the video again. So we're going to go back to table 11.2. Our last one was 11.1. Let's do 11.2. Sonia wants to have $15,000 in 10 years. Now, this is going to be done the opposite way, right? She wants to have $15,000 in 10 years. So we want to figure out how much of a principal she needs to put in at 6% interest to have that 15,000. So we're going to figure out what her original investment has to be. Now let's look at we already know it's 8,305.20. So let's figure out how she got there. And remember, just click on this thing and it'll pull up another screen, and it'll give you the a table. Oh no! Oh, I didn't mean to do that. That's right. But they give us an excerpt from the table in the explanation. So the compound amount or future value Sonia needs in 10 years is $15,000. Remember, I talked about present value and future value. Okay. Present value is what you have now. Future value is after interest and everything, what you will receive. We know that her future value is $15,000 because that's what she wants. She also knows somehow that she's going to gain 6% interest. So she may have bought a bond, something with a set interest rate that's not going to be reduced over a period of time. It's not like investing in the stock market or, investing in crypto. Certain bonds will have a set interest rate. Has anybody ever dealt with savings bonds? Anybody ever had a savings bond? When I was in the Army, we used to buy them all the time. And savings bonds is another way for the government to take money. You're actually a savings bond. You're loaning money to the federal government at a very small interest rate, but that interest rate is guaranteed. So And that's why there's a really safe investment, even though your interest rate's going to be super small, because it's backed by the full faith and credit of the United States. Okay, so your present value is going to be equal to your table factor times the compound amount. To use the present value table, the interest rate per period and the number of compounding periods need to be determined. Okay, so the interest rate per period is calculated using the nominal or annual rate, which is 6%, and the number of periods as follows. So 10 years, 6% interest compounded semi-annually. So in 10 years, you're going to have 20 compounding period total. All right, but we're going to use our nominal rate divided by how many periods a year, which is 2, 6% at 2. That's 3%, right? The total number of compounding periods will be the number of years multiplied by the number of compounding periods. We talked about that. Total is going to be 20. So we find 20 periods, and then we find 1.5%. So that is 0.74247. We're going to multiply times our future value. If you notice, it's smaller than 1. And so it's going to give you a number smaller than 15,000, which is going to be your initial investment or your principal. So I'm going to multiply the 15,000 times our table value. And so I got it wrong. Okay. Oh, I'm sorry. It should have been 3%, not 1.5%. So it's actually this number, 0.55368. So I gotta watch. I need to know what my interest rate is, how many periods it is. If you get it wrong, you got it wrong. And that's going to be $8,305.20, which is what we got here. So let's look at the problem. Let's slowly go through the explanation again. And they give you part of that present value table. So you don't have to go to the table itself. You do if you were doing a problem on your own, but since we're doing it here, they give that to us. All right. So okay, this is going to be table 11.2. It's the same process as you have here, so we're going to skip through it. Remember, nominal rate divided by periods per year is going to be your interest rate per period. All right, so they're doing it quarterly here, so that's 1.5% interest, and they're doing it for 10 years. So that would be 40. So we're going to find our interest rate per period, which we decided was 1.5%. And the period, there are 40 compounding periods. The number of compounding periods is greater than the numbers given on the table. Therefore, a new table factor must be found. This is calculated by first finding the table factor that represents half the period required. So 20. I decided to go back through this because I realized, so 20 at 1.5%, we get 0.74247. So there are 40 total periods, so half 40 is 20. So that's where we go to our chart. Multiply this factor by itself to find a new table factor. All right. So we're going to take this number here, We're going to multiply it times itself. So once again, we have something exponential. Here we get 0.55126, 0.55126, 1701. It, Excel brings it out farther. So the table factor, new table factor is this, times our original investment, which is 23,000, correct? Yes. So
Oh, no, you went awfully fast and my numbers are different for this than,
that's where you're going to use the same process, and you can go right back to this because I'm moving through this. You can pause, you can rewind, and then you can look at the explanation here. So you should be all right, Deidre, because I've seen you do math, so you're not too bad. So I multiply my original, or what I want for my future value, times the table factor, the new table factor we found. So 12,678.98. I got 12,679.02. And the reason I got that is because of a rounding error here, because I'm spread out a lot more than this. If you don't, when you do this with a calculator, you go to five numbers past the decimal. So it's tenths, hundreds, thousands, 10,000, 100,000. So you'll go to 100,000 place, that'll give it to you. So once again, I am going to start with the problem and slowly work my way down so people can see it. And this explanation is not something you're going to get when you do the problem. So I think this should help you guys a lot, hopefully. And I'm always available. And remember, you can always, when you're doing a problem, you can always go to that Ask the Teacher button. That button is very helpful. Although I may not get back to you for, a few hours, maybe the next morning, depending on, because I try to check it first thing in the morning. I try to check it in the afternoon, and then sometimes in the evening if I get a chance. But the evening is not always guaranteed. But whenever you give it, you can be guaranteed to have it by the next morning. Unless Bob gets to it first. All right. And I think we have enough time to get through this homework. We have table 11-2. See how many problems there are. 12 problems. Let's see if we can just muscle through these last two. Stuart Daniels estimates that need $28,000 to set up a small business in 8 years. So once again, we have a future value of $28,000. Okay. We have a time period of 8 years. All right. How much in dollars must Stuart invest now at 8% interest compounded quarterly? So compounded quarterly, that's 4 times a year to achieve his goal. So we have a table factor required, which is 2% over 32 periods, right? Because they're doing 4 times 8 is 32. And then when we divide our 8% interest by 4, we end up with 2% right here over 32 periods. We have our periods, we have this. Once again, our table factor does not going to go up to 32. So we're going to find half of that. So we're going to do 2% at 16 periods, and we're going to get 0.72845. All right, because we're going to follow the formula we saw before, which is just going to the table there. Since we cut it in half, this number is going to be the same. So we multiply this number by itself, and that's how you're going to get 32 periods, which is 0.53064 is our new table factor, okay, for 2% over 32 periods. So we're going to take what our investment is, or our present value is going to be that new number times how much money he's going to need for his future value. So he's going to need $14,857.92 invested now at what would we say, 8% a year for 8 years to reach his goal. Now, our compound interest is going to be our future value minus our present value, and that is going to tell us how much interest we accumulated over those 8 years. And so I'm going to see if I can come up, and you can see both the question and the explanation. All right, last problem on the homework. It's 5 minutes. I think we can get through this one. What do you think, Brandy? Thumbs up? All right. Suppose you wish to have $11,000. Let me just go to a new spreadsheet here. You want to have $11,000, so I'm gonna write 11,000 right now. In 13 years, so our time frame is 13 years. So our future value is going to be the 11,000. Okay, and this is going to be 13 years. All right. Use the present value formula to find how much you should invest now at 6% interest. So 0.06. That is our yearly interest rate. INTER interest. No. Interest. There we go. Now, they gave us another complicated formula here. Our present value is going to equal A, which is the compound amount. I is the interest rate per period. Okay, I is the interest rate per period expressed as a decimal, and N is the total number of compounding periods. So we have another exponent. To use the above formula, the interest rate per period and the number of compounding periods are needed. The interest rate per period, I, is calculated using a nominal or annual rate, number of periods per year. So he said he is going to be compounded semi-annually, so that's going to be every 2 years. So our 6% interest divided by 2 is going to be 3%. I know that's easy to figure, but let's go through the steps. If the given investment is blah, 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 that's what we just did. Nominal rate divided by periods per year, that's how we get our I. And our I is going to be right here inside. And remember, this looks awful familiar, doesn't it? Because we've already done that. The total number of compounding periods will be the number of years by the number of compounding periods per year. The investment accrues interest compounded semi-annually for 13 years. So 13 times 2, that is going to give us 26 of our compounding periods. I don't want to go over there. To use the present value formula, the interest rate per period must be expressed as a decimal, which is what we've already done. Converting I to a decimal gives 3% at 0.03. There are 26 total compounding periods, giving N to be 26. All right. So we have I, we have N. And then for A, we want to have $11,000. All right, so $11,000 divided by 1 plus 0.03 to the 26th power. Remember, we do PEMDAS. And if you can't remember PEMDAS, it's please excuse my dear Aunt Sally. Or when I was teaching high school, it was please excuse my dumb algebra student. So first thing we do is what's in the parentheses. So we're going to do 1 plus our I. That gives us 1.03. That was easy to figure out. Now we're going to take this and we're going to figured as an exponent for 26 periods. All right. So that means we took this number 1.03 and we multiplied it by itself 26 times. So 1.03 times 1.0 times 1.03, on and on and on. Okay. We don't need to do that because we have calculators now. So that gives us 2.156591. Next thing we do, remember, we do what's in the parentheses, then we do exponents, and then we do multiplication and division. All right. Remember that in a fraction, the actually division problem, it's going to be 11,000 divided by this whole thing. So now we take 11,000 divided by that whole thing, and we get $5,100.64, which is the answer. And we covered the entire homework. I'm really happy about that. All right, so I know, Brandy, you said you were in Bob's class, you had a kind of a hard time understanding it. This might help because you have the explanation step by step. Same thing for you, Deidre. You can go back to your big screen. You can look at it step by step and use your numbers. Okay. So any questions, comments? Anybody want to call me bad names, whatever needs to be said? All right. Well,
Guys, I gotta get the little one in bed, so.
awesome, Donald. I'll see you later. Well, I am going to stop the recording, which is the official ending of class.